Hey everyone, how's it going? Welcome back to another video. This is Jyotinder and I do LeetCode questions on YouTube. So if you're into that stuff, be sure to check out my channel and subscribe to it for more content. Right, so today we have a question that is called Course Schedule 2. It's a pretty interesting problem and it asks us that there are a total of n courses that you have to take, labeled from 0 to n-1. Some courses may have prerequisites. For example, to take course 0, you need to have first taken course 1, which is expressed as a pair 0, 1. Given the total number of courses and a list of prerequisite pairs, return the ordering of the courses that you should take to finish all these courses. Right, so you're given a number of courses and the prerequisite pairs, and you have to return an ordering of courses in which you should be able to finish all of them. Right, so they've told us that they've expressed each dependency as a pair of two numbers. So this pair of 0, 1 represents the fact that given if you want to do course 0, you first need to have finished course 1 before it, right? One course can have multiple dependencies. So in this case, we've only been given one dependency. So it means if you want to finish course 0, you first need to finish course 1. And in this case, you'll simply return back the order 1, 0, because if you'll first have to do course 1, then you'll have to go to course 0, right? To finish all these courses. Right, so you have examples here. For instance, you have 2, 1, 0. It just says that there is a total of 2 courses and the ordering or the dependencies are 1, 0. This means you have course 1, and to do course 1, you need to have done course 0. So the output would be course 0 first, then course 1, because 0 is a dependency of 1, right? So this is how you do it, and you can have a look at the other examples as well. So in case you have 4 courses, the numbers will be 0, 1, 2, and 3. You have something like 1, 0, 2, 0, 3, 1, 3, 2. This means that course number 1 has a dependency on course 0. If you want to do course 1, you first need to have done course 0. You'll have a dependency on course 2 of course 0, which means if you want to do course 2 first, you'll have to have done course 0 before this. Similarly, going forward, we have 2 dependencies for course 3, which are course 1 and 2, which means if you need to do course 3, you first need to have done course 1 and course 2. So one of the results or the outputs that you can get from this question would be 0, 1, 2, 3. So that once you do the course number 0, you can do course number 1. Once you've done course number 0, you can do course number 2. And once you've done both 1 and 2, you can do course number 3. So the thing is, this problem is a very famous, very standard topological sorting problem. It's called topological sort or dependency parsing, whatever you want to call it. And it can be implemented in a very simple manner using DFS. Right, so yeah, let's get into it. One small note though, I will not be covering topological sort and all its detail in this video. Like, I won't be covering the actual algorithm here in this video because I feel that would make this video very long. And there's already some really nice videos by Tushar Roy on YouTube, so I'll be sure to just link them down below in the description, so check that out. If you have no idea about topological sort, I would recommend you to watch that video. And if you have just a very basic idea, that should help you out just fine to follow along in this video. Right, so we'll need some utility classes here so that we can start off with this. The first one would be, we need to define an adjacency matrix because we will be representing all these prerequisites as a graph, right? So we will need an adjacency matrix. Secondly, we'll need a status array. A status array simply means it will keep track of all the nodes that we visited or the nodes that we are currently visiting, right? And why do we need that? Why do we need a status array? This is because they've told us that if it is impossible to finish all the courses, you have to return an empty array, which kind of hints at the fact that it's possible that it might not be possible to finish all these courses, right? To finish all the courses because there might be some cyclic dependencies. What do I mean by cyclic dependencies? Let's take an example for that. Let's say you have been given a pair, let's say 0, 1, 0, 1. You have a pair called 1, 2. Then you have a pair called 2, 3. And then you have a pair called 3, 0. So this means that if you need to do course 0, you need to have done course 1. If you want to do course 1, you need to have done course 2. If you want to do course 2, you need to have done course 3. And if you want to do course 3, you need to have done course 0. So this looks all fine until we get to this last dependency that we have. Let's understand why that is. So let's say you want to do course 0, right? Let's say you want to enroll for course 0. So you say, all right, I want to do course 0. But you notice that there is a dependency for this course or a prerequisite course for this, which is 1. So you say, okay, I need to do 1 before I do course 0. So you look at course 1. Now you realize that there is a dependency for course 1 as well, or a prerequisite for a course for the course 1 as well, which is course number 2. You say, all right, I'll do course number 2 first. Now you come to course 2 and you realize that there is a dependency or a prerequisite for course 2 as well, which is course number 3. So you say, all right, I'll do course number 3 as well. So you say, all right, I'll do course number 3. Now you see that the course number 3 also has a prerequisite, but this time the prerequisite is course number 0. So this means to do course number 3, you should have already done course number 0. But we realize that 3 is almost like a dependency. It's like a cyclic dependency of 0, because now if you want to do 0, you'll see that you come back here. You'll see that a dependency of course 0 is course 1. Then you have the dependency as course 2. Course 2 has a dependency as course 3. So this is like an infinite cycle. You'll be stuck in an infinite loop finishing all these courses, but you'll never be able to finish even one of these courses properly, because you have a cyclic dependency here. It's almost like a loop. So if you have a loop in your graph, that just means that it's impossible to find correct ordering, and you'll have to return an empty array in that case. So for that, we'll be using a technique called graph coloring. It's pretty easy to implement. It's really easy if you're using DFS, and the implementation itself is really easy. It's just the concept that you need to know beforehand, right? So be sure to check out some video that I might have linked down below. If in the future I end up making some video on topological sorting, I'll probably link them up in the cards somewhere, right? So yeah, let's first define all the utilities that we'll be needing. The first will be a vector, which will store the result. So we'll just say vector int res. The second will be an adjacency matrix. So that will be a vector of vectors. So that'll be vector int. I'll name that adj. Now you'll have a vector of integers which will store the status of all the nodes, right? So that will be called finished. So we'll say vector int finished, right? So what finished will have is, it will have the status of each of the nodes. A node can have 3 statuses. It can either be unvisited, it can be either in process, or it can be finished. Let's understand what I mean by that. Let's say if the value of a node in the finished array, or the status of a node or a particular course in this finished array is -1. That simply means that the node, or the, let's say the course, has not yet been visited, right? If the status is 0, it means the course has been visited but is being processed. So this means that we are currently finishing up the dependencies of this course that has the status as 0. So if a course has status 0, it means that it has been visited and we are currently processing its dependencies. And if the status is 1, it means that the course has been processed already, right? So if the status is 1, it just means that we have already processed this course, and all the dependencies have also been processed successfully, right? So when will you face a cyclic dependency, or when will you face a loop? You'll face a loop when you are, let's say, going through processing a course. When you start processing a course, you make the status 0. When you make the status 0, it represents that we have visited this course, but you are working through the dependencies. Now once you're working through the dependencies, in case you visit this node again, in case you visit this course again, you'll see that the status is 0. It means that the dependencies were not yet completely passed, but you already visited this course again, or you came across this course again as one of its dependencies. So it just means that you have found a loop, because this course was not yet finished processing, but you face it again. It means that this course is a dependency of itself somewhere down the line. So that would just mean that there's a loop and you just have to return back false, right? All right, so let's see how we'll implement all of this. So they've passed us 2 parameters, which is num courses, and the second is the prerequisites of all the courses. I'll just rename this prerequisites vector, or this matrix, to pre, so that it's a little easier to write. All right, so the first thing that we'll do is initialize all these utilities that we defined above. So we have the finished array, and that will be initialized with a vector of integer type with num courses number of elements, each of them initialized to -1, because initially each of them will be unvisited. Now we'll define the adjacency matrix. So we'll write that as a vector of vectors of integer type, and we'll have num courses entries in this. So num courses, and we won't be adding any initial value. Alright, so now it's time to populate this adjacency matrix. So all we'll do is simply traverse through this matrix that they've provided us, and we'll turn that into a graph. So for auto, let's say P through prerequisites, what you want to do is, you want the first element is the course and the second element is the prerequisite. So for a particular course, which will be P of 0, we'll add a prerequisite by pushing it back into the corresponding vector. So we'll push back P of 1, we'll push back the dependency, right? Once you've done that, you have populated the graph. So once you're done with this for loop, you will be done with populating the graph, and you can start doing the actual traversal. So in topological sorting, there is no actual method to start off. You can start off at any of the nodes, it doesn't matter. All you have to take care of is that you should not face a cycle at any point, right? So you can start off at any of the nodes, and you can have multiple answers, so that doesn't really matter. And if you face a cycle at any point, you simply return back, and in this case we'll have to return back an empty array, right? So let's say we start off in the correct ordering. We start off from 0 and go until n-1, right? So let's do that for int I equal to 0 while I is smaller than n plus I. If the topological sort or the DFS function returns false at any of the points, we'll return back an empty array. So we'll say if not DFS of I, if this is the case, we'll return back an empty array, right? Otherwise, we'll return back the result array, the res vector, right? Which will be populated in our DFS call. So now comes the actual implementation of this entire algorithm, which is the DFS function itself. We'll be implementing graph coloring, we'll be integrating that into the DFS call, and you'll see how easy that is. So we'll be defining this as a boolean, bool DFS. We'll take only one argument, which will be the starting node. Now, we need to check the status of this current course that we are looking at, the starting course. The status can be one of these three. It can be -1, which will mean this is an unvisited course and we can start parsing its dependencies. It can be 0, which would mean that this course has already been visited but is being processed. And in case we encounter a course with the status 0, it would mean that we were parsing the dependencies of that course, but we visited this course again. It just means that this course is a dependency of itself, which means that there is a loop. There is a cycle in this. So we'll simply return back false in case we visit a course with the status 0. If the status is 1, that will simply mean that this course has been processed, all its dependencies have been processed. Hence, we don't need to look any further and we can simply return back, and we can return back a true. So let's see. Just a second. Yeah. So if we write if finished of start, if that is equal to 1, return back a true, right? Otherwise, if finished of start is equal to 0, if that is the case, you have to return back false, because this means that you faced a loop or a cycle in this graph. So return back a false. This would mean that you can't really get a correct ordering. So if none of these actually return anything, it means that the status of the current course is -1, which means the course has not yet been visited. So you will start processing this. But before you start processing, you will mark this course as an in-process course. So you'll mark this course with the status 0 because you're starting the processing of this current course. So you'll just say finished of start equal to 0. So that you can tell that this course is is in process. Now you will start going through all the dependencies, and now you will start clearing all the dependencies in a recursive order. So to go through all the dependencies, we'll just go through the adjacency list. So we'll say for auto dependencies, I'll just say dep. You will simply traverse through the adjacency list. So that will be adj start. So while traversing this, if at any point the DFS returns false, that would mean you face the cycle in passing the dependencies, and it will simply return back false, right? So if DFS of the dependency returns false, you will simply return back false here as well, right? And if this executes successfully and you did not return false at any point, it means that all the dependencies have been passed and this current node has finished processing. So you will mark the finished status of this current node as 1. And now, if you completed the for loop successfully, it means you already passed all the dependencies and you've added them to the results in those recursive calls. So now you can push the current course as well into the resultant array, because you've already passed all the dependencies, you've already processed them. Hence, now you can push back this result, this current course into the result. So you can say res.pushback start. So you, first of all, you mark the node as in process, then you parse all the dependencies. Once you've passed all the dependencies, you mark the current node as finished, and finally push it back into the result, because you've already pushed back all the dependencies. Now you can push back the course itself, right? And once you've done that, all you need to do is return back a true. All right, so that should be it. And let's run this and check if this implementation is correct. All right, so it says undeclared identifier n, so this will be num courses. All right, so it gets accepted. Let's submit this. All right, so we get 65 milliseconds, 60 milliseconds. That is perfectly all right. Right, so this is how you solve this problem. And if you like this video, hit the like button and let me know if you want me to do a topological sorting video in which I explain the algorithm in complete detail on a whiteboard, and I'll do that, right? So yeah, so hit the thumbs up button if you enjoyed this video. Subscribe to the channel if you would like to see more content, and I will see you in the next one.